Hey everybody, I'm Austin. I'm here to talk about, AI and BigQuery. I'm glad to be here I'm in here from San Francisco. Flew out, my sister went to college nearby at Siena College and met her boyfriend, now fiance, who graduated from here in 2017. Never been around, so it's been nice to explore. Let's see. Oh, hey, what's up? Who is this guy? What is he doing? Whatever. I don't know. It seemed like I should throw some logos or whatever around. These are a bunch of places I've worked or done work for. Currently, I'm an architect at a company called Azra AI. We work on, we'll call it the cancer journey, from identifying those in risk to tracking their journeys through the hospital system, making sure they get the care they need as early as possible through hopefully a healthy recovery. This is another slide I got from our marketing department, right? So just doing a little bit. I think it is actually a really cool platform that actually helps people much more so than some of the other places I work that, are just entertainment or just ads or forgot a few other logos of places I've been. Cool, so overall, AI is worthless without data and BigQuery is an awesome tool. So I'm gonna talk about that ecosystem a whole lot. This is a DevFest, Google focused, and otherwise, I've had the opportunity to work on a ton of the different clouds, and I found this to be ideal. I just realized I created all of these slides with the intention of being able to share them, and there should have already been a bit.ly link for you guys. So let's find the right deck, maybe. Oh, that's why this is the... let's go here. Slides. Let's go this deck, because then we have this. For anybody that might want to have these later, I'll also make sure to share, because I littered the presentation with references of stuff to check on later. All right, so let's actually present slideshow. All right, cool. So that's the stuff, BigQuery. Cool tool, that's the logo. Why? Hey, you gotta store some data to do anything with it. BigQuery storage is awesome, it's managed effectively, no ops. I used to talk about it in terms of any scale, right? Because it worked well for my, little files that could fit on my desktop, to, I've used on many petabytes of data. Super durable. Nothing in the cloud is 100%. I think with the exception of Cloud DNS actually has a 100% uptime guarantee, but otherwise 11 nines of availability. Most SLAs, service level agreements for cloud services, talk about how many nines of reliability, durability, availability, et cetera. So you can imagine even with a whole lot of potential objects and data points, it would take a whole lot of time before on average you lost anything. Encryption for data is pretty critical. So you can have Google manage it for you or have your own keys, and maybe you are thinking about columnar storage for data. Google has their proprietary capacitor format, which they manage for you, but the ability to slice on, say, individual columns of a database makes things more efficient. For those that may use BigQuery, it just struck me, hey, here's some cost tips. Keep your costs down. People like not spending money if they don't need to. There's two different billing modes for BigQuery. So, and I'm starting with, we'll get to some AI and ML stuff, but this is really critical, although it may be less of interest, so we'll see. You are opted into logical billing mode for BigQuery, but be aware of physical billing mode. If you're not updating your data and it's just adding new records and those are accumulating over time, you can just press a button and switch to physical billing and save a bunch of money. At one job I worked at a couple years ago, after this feature was released, I was really able to press a button and save us over $100,000 a month. Make sure to lay out your tables. Partitioning, and this goes for beyond BigQuery. You can kind of have data layout in such a way that when you retrieve it, it is more performant. So slice usually on things like date for a partition, and cluster, otherwise also known as Z-ordering in other systems, for grouping data together for more efficient retrieval. I really like BigQuery for its shared storage layer. So they have what's called the BigQuery Read API. In addition to the compute that can query the data via BigQuery, you can also point things like Spark or GCP Dataflow or other things to read the same data. That got released, I want to say, about 2019 and was a major selling point for me adopting this technology at the enterprise I was at the time. Nowadays, you may hear more about Iceberg. That's the little logo for it, an open source project that kind of does similar things that works in a whole lot of places. Iceberg now also works as a storage layer for BigQuery. BigQuery has a ton of tools for keeping your data governed, managed, indexed, etc. Here's a bunch of cool stuff, right? In jobs, I have to worry about which sort of contractors are able to access which data in which ways. You can restrict data on individual rows. You can restrict data on individual columns. I more generally use authorized views, meaning here's a SQL query that is a view that says, hey, you can have all the records where the customer ID is this, or matching these criteria, or whatever, and then give somebody only permission to read those things. I really like the ability to have descriptions. Lots of people have weird named columns for their databases, kind of old habits, or trying to save bytes. There's room for metadata to say exactly what that is, or say a join key to another table. Tags for the same thing for policies, for information about it. We can mask data, and we can use things like DLP, data loss prevention. Dataplex is another part of governance and management. I don't know why we have all these different names, but data lineage is very, I would say, pretty critical to understanding data systems. As you get into more business focus, because it looks to me like a number of your students, right? It's no longer, here's your one data set, do something with it. There's potentially chains and chains of enrichment and going from one system to another to grab this other data to enrich it, and understanding the data lineage. Where did it come from? What has happened along the way is important for a lot of context, and also to debug problems. Having metadata about stuff, critical. Profiling, understand your data. It will help you figure out what's the sort of distribution of values. And data quality. Do the values in specific fields match specific expectations? BigQuery does this at the end, which is usually most convenient for a lot of people. I would encourage more as a data professional, get data quality as upstream as possible. Check your values before you insert them into the database so that you don't actually need to rely on features like that. BigQuery is awesome for not only are you storing it in there, but you can use BigQuery's compute to grab lots of data from different places. S3 is storage on Amazon. You can use a bunch of Azure clouds storage, Salesforce Data Cloud, AWS Glue. Bigtable is a non-relational database for big-ish data, right? You can connect Google Drive. I mentioned Iceberg before, and Delta Lake is an equivalent technology to Iceberg from Databricks. In addition, there are what's called federated queries, very similar, which can read from other databases. That's very convenient to not have to make copies of data to different places. You can think even as you're trying to do analyses or train models, getting data all in the same accessible location without having to move and make a lot of copies is very valuable. This has gotten way easier and easier. Here's a whole lot of other links of little features, right? You can do logical views. Logical views are basically just stored queries, right? Shorthand, so you don't have to copy and paste the whole thing. If you're using them in similar ways, you then surface that like it is a table to other people. There is also materialized views, meaning it actually writes a copy, performs kind of the aggregation and stores it for you. It materializes it. The reason you would do something like that is for performance. Then it doesn't have to recompute what's going on, but the data is kind of computed on write in the various formats that you need to use it. We will look in a moment at some user-defined functions, right? Not everything is expressible in ANSI SQL, the traditional SQL. You can use user-defined functions using JavaScript or Python these days. There's user-defined aggregate functions for when you're not doing, say, per record transformations, but you need to do larger aggregations over more records. There are table functions that return tables. There are stored procedures like other database systems. A very recent bit, which you may hear about more often, is vector search, right? AI needs, or people really like using vector search for some very specific AI applications. And you can use search indexes to speed things up. Okay, cool. BigQuery has built-in what they call Colab Enterprise notebooks. Colab was initially kind of like Google Docs for Jupyter notebooks. Jupyter used to be IPython notebooks. For anybody doing anything with data, I assume the college has shown you these things, but a hosted environment with usually a Python interpreter that you can type your code in and at least prototype stuff and find ways to get it closer and closer to production. So let's, so that I'm not only showing slides with whatever it's called, links, let's actually pull up and like, hey, what is this guy talking about? Let's go here. To the cloud. All right, I put some examples together last night because I didn't bring my work computer, and this is then what I got. Have a new GCP project here, BigQuery A share. There's lots and lots of services, but especially we're interested in BigQuery. And in BigQuery, you can have connections to those external things. You can type just SQL queries if you want. You can have notebooks. So let's just look at a notebook. All right, so my project is BigQuery A share. That's cool. And there are a ton of public data sets available, right? Obviously, I can't share my work data sets that are patient data at a lot of hospitals around the country. So we'll, digging into the publicly available data sets. I like this one because it was pretty first in alphabetical order, and since my name's Austin, it stuck out to me. So I mean, in this, it's as simple as saying, hey, even BigQuery, this is actually a Python environment, but using magic BigQuery, type a SQL query. And in this, there are, I guess, 101 stations in Austin for their public bike share program. This is a little extension where, for those writing some code might be familiar with pandas, this can either use, I think we'll display in different, this is BigQuery or Colab Enterprise table format versus the default for table displays is pandas otherwise. Did I do this? So you can also do, what is this, df, and then df, let's go peak. And it should, whatever, let's just do df. Okay, so using that shorthand too, we'll take that query and make that a pandas or BigQuery data frame. So we're going to talk more about that in a second here. I think that's the other slide deck, so maybe. All right, cool. Definitely, I run into all sorts of troubles in new projects. You got to enable a whole lot of APIs. So just highlighting, I've already done that. That's why that just worked instead of not. I guess back to here, the kind of magic, I guess, is all the networking, permissions, et cetera, all really worked out by being logged in to my Google Cloud and just my Google account more generally, rather than running this locally, type in Jupyter Notebook, whatever, that's more limited on compute. And this is smart enough both to have some compute available to me and also turn off when I'm not using it to not charge me lots. Okay, so that's notebooks, kind of more general. Yeah, I push my data science group at work to be using this more and more. We had been either running things locally off our laptops or spinning up a larger and larger just virtual machine that even then our data scientists were sharing, and then running into resource issues, stepping on each other or not remembering to turn off the machine at night, et cetera, right? So the move has been you guys will use those notebooks as is unless there's a compelling reason that those are insufficient, and nobody's come up with one that has been sufficient yet. So I guess to highlight too, I'm trying to take you guys through the maybe journey of, hey, I've been working with especially BigQuery for more than a decade now, through some stuff I've been using more recently, some stuff we're just starting to try, and eventually, hey, here's some stuff that looks cool that I actually thought I was going to spend some time with before I got here to talk about, but some pointers on where I know I'm going to look at, and I hope that you guys do. Okay, so I think these are awesome, BigQuery data frames. So hopefully, again, you guys are familiar if you're doing data-y things with Python of pandas. BigQuery data frames are like a pandas compatible APIs, but pushes the compute down into BigQuery. Pandas itself has been largely memory inefficient. As it got started, it stored everything in strings. It's gotten a whole lot more performant lately, but this is even, incredible integration. Hey, use these APIs and push the logic down into BigQuery's compute. That's why, for instance, in those notebooks, you don't need massive amounts of compute because the compute is happening in the BigQuery backend. In addition, there's BigQuery ML components. Cool, let's see some more. All right, so I think I have a 2 somewhere. Notebooks, 2. Cool. Also, notebooks install a whole lot of good tools themselves. If what you need didn't, you would use a shebang pip install, for instance, for those that are familiar. Again, this project is that. So I'll set the project. I'll set my region. This can also be auto-retrieved, but whatever. I need to import the actual bigframes.pandas. I think did I set my region? This is gonna, all right, cool. And then a different, because I wasn't creative enough, I found some docs and I just copied some examples. So this is Wikipedia page views, public data set. BigQuery data frames lazy loads. So that's why this was pretty quick. But when I go here, it'll actually say go get the data from, I don't know, whatever, 2000, and give me the top 10 rows of that. So that'll take a moment, but not forever. Did step through this all to make sure it worked. So I feel good about that. I see a question. Go ahead.
So you're saying that this process right now is running on BigQuery, it's not on the Colab CPU?
Correct.
And this is something that you can have only in Colab device?
There's, no, actually. BigQuery data frames is something that you can run from anywhere. It's a Python package just like Pandas. So assuming you set up all your connections appropriately, right, even from your local computer running a Python script, not in a notebook, which I do as I start to productionize processes, right, get them out of the notebook, get them in, in more tightly controlled version control, linting, all those really good CI practices, which we'll talk about in a second. But yeah, when it's set up correctly, even your local computer could go do that, which was, went and grabbed 65 gigabytes of data and then just showed you the first 10 rows of it.
Is there an equivalent of this in, let's say, Azure or AWS, or is this unique to Google?
I don't know. I've kind of stopped. I intermittently do, we'll call it market intelligence. My life would have been a lot easier if, especially years ago, Google Cloud's tools, especially around BigQuery as a data professional, weren't vastly better than everything else because that had such a smaller market share. I'm very enthusiastic about the future going forward. Even some announcements I saw this week on how we'll say they're catching up, and especially via AI in terms of market share, right? Because there's the like, hey, do you go where there's, as maybe a student, do you want to learn the thing where there's larger market share and maybe more jobs, or do you want to go maybe where things are going, or do you want to use what seem like the most convenient and best tools? I can't be prescriptive on there. I just know it was clear I could do a whole lot more myself with these tools without needing a large team, and even advocated at the Fortune whatever companies that I was at for these things, because it made more sense to scale a smaller group that could accomplish more than just throw more bodies at things because the tools weren't as nice. Again, full disclosure, we're at a DevFest. I'm also a Google developer expert for cloud, right? So I'm biased, but I try to not overly be, but my company's fully built on Google Cloud, so I only have so many hours in the day. I'm looking at tools that I'm definitely not going to use at work as hard. Yep. All right, so cool. And then for those familiar with pandas, then hopefully this looks kind of familiar. It's saying, hey, go get from this data frame, go look if there's a string containing this regex expression of Google, either upper or lowercase, in the title field, and give me the count of the views descending, right? So again, and this isn't actually it might, come to think of it, It potentially would have taken longer. BigQuery also caches. I didn't think about that until right now. If you've run the same query before, it keeps that available in cache for 24 hours. So that's why that was so quick. But really, I don't think it took more than seconds when I ran it the first time also. And I mean, frankly, if you're worried about a few seconds here and there, that helps. But for this sort of manual analysis isn't the right thing to be optimizing for. Cool, all right, so that's like, hey, this is, I think, crazy powerful. Getting the, not needing a massive machine to do your local computations. For those that are, especially in more data analyst or data scientist type roles, doing data exploration, et cetera. Otherwise, companies or yourself are potentially wasting a ton of money having way more power, on and just sitting there. That's one of the powers of the cloud, right? Kind of on-demand compute. As you get further along, then you'll get into enterprise discounts and how you actually want to commit to a certain amount and then pack that as much as possible. But for exploration, you just want, give me all the compute for a few seconds or a minute or whatever it is, and then go away. So cool. All right, let's go back to some slides. That was BigFrame. So super cool, I think. Calling out the data engineering agent. Right now we're getting more AI focus. So this actually went into public preview Monday, I'm pretty sure. I also include the link because there's a sample. Google has something called the Agent Development Kit, similar to LangGraph. For instance, super well integrated. Though, data engineering agent, I haven't worked with. I got preview access a while ago, but they're really focused on data form. Data form is one tool in the class of also DBT for those that are thinking about such things. I think of those two as largely equivalent, and then SQL Mesh, which I found highly compelling. So I was already down the train of adopting SQL Mesh, so I haven't taken the time to play with data engineering agent. The team has said they'll eventually look to expand those other integrations, but it wasn't going to help me with the specific tools that I needed. But it is made for, hey, chat with an agent, human language. I need a pipeline that does this and helps generate that code. The things that I've seen look good if you're, we'll call it wholly using the tools it supports currently. That's the 80K logo because this slide just seemed too bare otherwise. The data science agent. So there's a data science agent built into the Google Cloud Console for BigQuery, for instance. Type, hey, I need to perform this computation. Generates the BigQuery data frames, the whatever sort of code needed. I don't think I made an example about that, but I can probably demo that in a second. Let's talk about some other cool features at least though. Built-in ML functions, right? Lots of stuff have this, right? Hopefully a whole lot of these internal models look familiar for those of you thinking about data science at least, right? So you can call them directly from the SQL in BigQuery even, separate from it working with functions. We'll see in a second there's increasingly 5 different ways to accomplish the same thing also, right? So it's, that becomes either a stylistic preference or, now from where I sit in more technical leadership, trying to arrive at some sort of consensus and get everybody at least in the same group, if not the company, doing things the same way. BigQuery ML, in addition to those internal models, supports calling your own external models in TensorFlow format, in TensorFlow Lite format, using XGBoost or ONYX, which is compatible with PyTorch. We use PyTorch at Azra, and you can have them in that format. Otherwise, let's see, BigQuery A. Oh, so remote models for LLM, especially generative AI models, things in GCP's Model Garden. For those, hopefully you guys are paying attention to Hugging Face's, pretty nice and prolific ecosystem, agnostic of cloud. And then, some other logos there, right? Llama, Anthropic, and Mistral are partners. Those all work with BigQuery remote models to be able to call those directly from SQL. I'm seeing now that it would have been a lot more powerful to have some other example. Oh, cool. All right. So here's like basic syntax. You would host those external models in a Vertex endpoint, not too difficult to get spun up, and this would be in your SQL interface. In BigQuery, for instance, create model, create if it doesn't exist, or replace it using a connection at this endpoint. And that way you can call that. Let's see, BigQuery AI operators. Okay, cool. So I can use AI in a number of ways. This is a relevant code lab that I thought was pretty good to filter data, to classify data, or to score data using, again, natural language, saying, hey, filter stuff that doesn't match these conditions. I mean, by the time, a lot of this stuff I think is by the time you actually understand it well, you don't need these functions because like writing the actual code to do it's just as easy. But for those, until you get enough experience to do that, here's, we'll call it shorthands or, productivity boost. BigQuery ML has a ton of stuff. Evaluate, Google Cloud has a bunch of Vision API, Translation API, Natural Language API, Document API, et cetera. So those sort of external models, as referred to before, have direct integrations, again, with BigQuery, so you can call those sort of APIs better. Let's see, Gemini and BigQuery. Okay, lots of helper functions there. I think I skipped a third notebook I wanted to show, so let's dig into that. I don't know what else. Oh yeah, okay, cool. So let's go here, remote functions we talked about. So again, we have big frames. If I have a file, say local, or that I would store in GS, Google Cloud Storage, the equivalent of Amazon S3, for instance, that's stored as a CSV. Hey, in general, please don't use CSVs if you can help it. They're still around, just like SFTP is around. There's better options these days. Lowest common denominator or whatever, it still works, but just, if you have the choice and are generating stuff, I at least push everybody like, all right, Parquet is at least more common, then I don't deal with escape characters. I get the benefits of columnar that I highlighted before. There's some compression, et cetera, et cetera. So just for whatever that's a little worth. This will load a data frame using BigQuery data frames, loading that. Okay, there's the peak. I can, for instance, say project. I can use this client to now create a data set in BigQuery. And once I have, if not, this is the kind of cool bit to and from. The data frame that I loaded from this, okay, it's a solid data frame. Now I'm saying go to Google BigQuery. That's an option. If it exists, go ahead and replace it. But it's saying, hey, go create in my BigQuery AI share, in the data set I created, a penguins table. That's really straightforward if you guys are used to working with data frames to be able to create tables. So then you can query if you need, and again a peek. You can use that sort of syntax to just grab an individual column. You can use the kind of usual pandas functions to get an average. You can do the sort of group by different stuff and get a mean. And so I agree. I didn't actually even read that error, so hopefully it wasn't important. Getting code that runs at scale is often a challenge for analysts, as this kind of says, or data scientists. So there's a number of, I think I alluded to, both remote functions and user-defined functions. With BigQuery data frames, you can declare remote functions using a decorator. And then this should just look like a normal Python function, right? Get bucket. So if these are options that at some point you may pay attention to but are not critical at the moment. So if I decorate this function with a remote function, it will create that as something that then exists as a cloud resource that can get called. Cloud function has a name and a location, at which point I can take this data frame that was created, where is that, here, from this, and I can apply my getBucket remote function. Again, this is arbitrary code, so this can be a whole lot more complicated than that, but it's basically saying if it's above or below 3,500. Again, we're seeing this bit. And that's, hey, if it was 3,150, indeed, yeah, it's below 3,500, right? Pretty basic math. To weirdly go the other way of things, this user-defined functions I generally find to be more simple. Oh, getting wrap up here, so cool. The same sort of decorator can be applied. So you can have a user-defined function. In this case, you can call external packages that get installed, and this performs a little bit more, has an import, performs a little more other query. Again, I don't know if this is doing justice to how powerful these decorators are that are then creating cloud resources based on just the decorator. Then this will create hashes for if we considered those to be sensitive data. We've already talked again about other ways we can hide sensitive data. All right, let's see. I think we're kind of about there. Oh yeah, so then last bit, I think a lot about Gemini CLI. I'm using it way more than notebooks, but I also collaborate massively with a bunch of, or more of my time's focused with our wider engineering org, not just data science. But super cool as relates to BigQuery. There's an MCP server for that, but I find that to be a really nice tool, and getting things deployed. Everything we just walked through would be highly prototyping. You could do some great analysis. You could train some models. Just a reminder, exploring all of that doesn't impact a future business unless you can actually get it deployed into production, served, it doesn't break, it produces business value. We didn't really get into that, and then here's the slide deck again, and I think that's it. So that's what I got.